All right, good morning, everybody. This is going to be like a weird room. I'm going to have to kind of split. So I'm going to have to go like swinging left, swinging right. So this is, or I can just speak to the wall, either way. Welcome. So my name is Eldon. I'm from the Windows Server group. We've got Kevin from the SQL Server team. We also have Morton, who's a customer, who's going to talk about some of his experiences. Just to make sure you're in the right room. So what we're going to talk about today is we're going to talk about why Windows Server 2016 is a great platform for SQL 16. So you're going in, let me just ask, how many people in here would just kind of self-identify themselves as like a SQL person? Oh, a good chunk of the room. How many like I'm a Windows person? Wow, it's like almost split. That's like a 50-50 split. Okay, that's interesting. So what we're going to talk about is when you're making an OS choice and you're going to go and deploy SQL Server, and you might go, well, why do I care? Why don't I just use 2012 R2? Why don't I use 2008 R2? What's the real value prop and what's the difference and why do I care? And that might not be intuitive first. That's what we're just going to cover in this session. We're just going to go through all the different value props of why running SQL 16 on Windows Server 16 is the most interesting. All right, so the first aspect I talked about is it's the most secure by default. So just looking at what's our track record? So let's ignore 2016 for a minute and let's just talk about what has been our track record. So we really have unparalleled security. Over the last 6 years from a database perspective, if you look at the last 4 years from an OS perspective, if you look at kind of the vulnerabilities. Also, if you look at SQL versus Oracle versus MySQL, we just have a great track record of what we've done over the last couple of years. Let's talk about 2016 for a minute. So we also have a number of innovations coming in Windows Server 2016, which are going to make it even more secure and even better yet. So you've got just enough administration so that you can assign different admins to do specific tasks. So you want somebody to be able to look at things but not modify things. You want them to be able to modify a specific thing, not other things. You can have that fine level of granularity and control. You can do just-in-time administration. You can say, hey, you can do administration during this maintenance window, or only during 9 to 5, or only on the weekend, or only on Monday, or you have a contractor coming in, and you say, okay, I'm going to assign them permissions. It's just going to be for a month. So this account will be active for a month, and it's going to stop working. And we have a bunch of also integrated aspects. So Defender's now in box, enabled by default. So you have, for known anti-malware in box, you've also got like control flow, which is for protecting against unknown. And then we've also got like a credential guard, which prevents against like buffer overflows and things like that. So there's a number of just security enhancements in box, which are going to make this, we have a great track record moving forward, and it's even better moving into 2016. So if you care about security, it's a no-brainer to know this is the platform to go with. So let's talk about flexibility for a second. And with that, I'm going to bring up Kevin, who's going to show you guys a demo. This is going to be a weird demo. Usually we always talk about something. Then we show you the demo. Here's the clicker.
Okay, thanks. I haven't had quite as much coffee as Eldon has this morning. So this is a mystery demo. I'm going to show you a demo, and you get to tell me what the feature is. So this is about availability groups. How many people know about availability groups? Cool. So we're going to create an availability group on this system here. So we've got two systems we're connected to in Management Studio. They're going to use the new availability group wizard. Usual process, going to give it a name, something really original, like my AG. Right? Going through here, everything is just normal, like you've done it before, either with the wizard or if you script it out. Nothing is the same, is different. We're adding two different replicas, right? So connecting to the other one. One and both automatic failover and synchronous, so you've got full HA along with your disaster recovery capabilities. And data synchronization, I'm going to use join only because I've already got the database staged in a restoring state on both sides. Next, validation. Yeah, everything looks good. I didn't create a listener for this exercise, just interest of time. And we hit go. Everything succeeded, right? So what's different? Anybody have any ideas? Show the dashboard, healthy availability group. Any idea what's different on this one? Anybody? No, it's all in the same cluster. The ownership is just like normal. Is there what? So they're both domain joined. So you have cfdev.nttest on one machine, and flip over to the other machine, different domains. So the restriction has always been that all nodes within a cluster, and therefore all nodes within an availability group, have to be in the same Windows 80 domain. That's no longer true. So now you can have them in different domains without trust, or in no domain at all, and Eldon's going to go into all the Windows details on this.
All right. So as you've known, for the last 2 decades, we've always required all the nodes within a cluster to be domain joined and be in the same domain. As Kevin just showed you, Kevin showed up to me and he was like, hey, we need more. And he was really about availability groups. He's saying, hey, we got availability groups, they're going to be stretched across locations, and customers want to be able to stretch them across domains. So we said, we got to make clustering work to be able to be compatible now across multiple domains. So now you can have nodes which are joined in different domains. Another thing we also support is he also approached me and said, hey, Eldon, so it's great we want to have AGs that be able to can survive across different domains. We also have customers who are using database mirroring today, and they want to be able to move to availability groups, but they find an inhibitor that they have to now be domain joined. We have database mirroring using non-domain joined systems. We need to break down these barriers that clustering has had for the last 20 years, that I can now deploy a cluster and not be domain joined. So that is another thing that is new in Windows Server 2016 is you can deploy, and we really did this for SQL, be able to deploy servers that are not domain joined in a workgroup mode and then deploy SQL on top of them. All right, so next thing I want to talk about is about upgrading. How are you going to get to 2016? You're in Windows Server 2012 R2, you're going to get to 2016. Is it going to be painful? It's actually going to be your easiest upgrade ever. So here's some of the things that we're doing. So the newest thing that we support is you're going to be able to do a rolling upgrade from 2012 R2 to 2016. That means that you will be able to have so here I've got your 2012 R2 SQL cluster. I've got 2 databases running on here. You will now be able to evict a node, put the new OS on it, and then bring it back into the cluster. So that's one thing you could do. So you can actually evict, format, reinstall, put 2016 on it, bring it back in. You can now work in mixed mode. So you can have some nodes that are down level and some nodes that are up level, and you can transition through them one at a time. So you can remove one, bring it to 2016, remove the next one, 2016, remove the next one, 2016. The other concept we introduced here is something called a cluster functional level. So the cluster will actually operate at a down level compatibility until you get all the nodes upgraded. And then we have a command that you switch that switches all the nodes in the 2016 mode called update cluster functional level. And then that will upgrade all the nodes. Now another thing we support for the first time is the ability to do an in-place upgrade of a node which is domain joined. So I talked to some customers and half of them say, you know what, I would never do an in-place upgrade. But a lot of SQL customers I got to talk to, they say, hey, save me the pain of having to reinstall and reconfigure SQL. I don't want to have to evict the node, format, reinstall SQL, reconfigure it, bring it back in, add node, do all that stuff. That's just a lot of work. Can't I just run setup and do an in-place upgrade on the node while it's still joined to the cluster and then run in a mixed mode and then roll through all my nodes doing an in-place upgrade without having to reconfigure everything? And the answer is yes, you can do that in Windows Server 2016. So again, you just roll through the nodes one at a time. You'll fail over your instances as you're going, and you get yourself to 2016. And then you just run the commandlet to upgrade the functional level. Another thing that we support is we have a new feature in box called Storage Replica. So if you wanted to do, let's see, deploy like a stretch cluster with an FCI, what was our story? We've supported stretch clusters forever, since Windows 2000. What was our answer for the last 16 years? We would go, when it comes to the data replication, we'd say, yeah, here's what you gotta do for quorum, here's what you gotta do for networking. We did a bunch of enhancements around quorum and networking. But what'd you do when it came to storage? We'd say, blah, go call your storage vendor of choice, get out a giant checkbook and write them a big fat check, and they will give you some storage replication to figure it out for you. That's now gonna be in box in Windows Server 2016. So you'll be able to do an end-to-end stretch cluster. And with that, I'm going to bring up Morton. It's one thing for me to talk about it, but I'll bring up Morton. He'll talk about his experiences.
Thank you, Elton. I'm Morten. I'm working on infrastructure with the largest transport and logistics company located in Denmark. We've been using Windows Server 2016 in production for quite some time, and I only have 10 minutes before Elton and Kevin kicks me off stage, so I'll get right into it. So a teaser customer testimonial. I'll go through some of our recent infrastructure journey that we hope you can relate to. Our business, we have hundreds of dispatchers and thousands of drivers roaming the flat Danish country every day. A long time ago, we developed these IT systems that replaced many of the manual operations on a day-to-day basis. We did real-time systems that enabled us to decentralize the decision-making between the dispatchers and the drivers. And we have massive amounts of small data sifting through our databases. Notifications pushed around, all important actions get recorded, along with the scanned barcode, the geopositions, images, billions of rows. And of course, the data has become valuable over time, both in terms of business intelligence, internal business intelligence, and external analysis projects. We are data providers, especially on geopositions. The Danish Road Directorate are interested in doing analysis on heavy traffic. And we are doing projects with a Danish university doing analysis on traffic speeds and traffic congestions. So point being, from a database administrator and an infrastructure perspective, this is a challenge, classical challenge. The OLTP systems, the popular systems are starting to become more and more mixed in terms of also doing reporting and business intelligence. I'm sure you can relate to that. So naturally, a while ago, we started to hit some challenges in terms of performance. We do have a great .NET software team, but it is difficult to always predict how users will use the applications and how the business intelligence will affect the databases. So we have spent hours on application architecture, tuning queries, optimizing distributed transactions, tuning SQL instances, spreading the I/O load, archiving data, looking at readable secondaries, and much, much more. But eventually, as the scale of our entire ecosystem of software was growing continuously, we were seeing more and more bottlenecks in the I/O subsystem, and we needed to do something. And our infrastructure was aging. VMware, SAN, and spinning disks. So we have been working alongside a Microsoft MVP, Michael Fransen, who has been helping us introduce a very fast, all-flash-based converged infrastructure. So we have continuous linear scalability on the storage. We also switched to Hyper-V. We decided to do a massive SQL consolidation. We had 100+ SQL instances, 600 databases. It became 8 SQL clusters in total. And we did a dual-site infrastructure with all of this good tech stuff, the scale-out file servers, the offloading features, single root I/O visualization, RDMA, high bandwidth and low latency, InfiniBand, tons and tons of terabytes of redundant storage arrays. All flash, all good, and it has become much cheaper in recent years. Very good business case for us. We have two data centers, so very good business case for us. And when you do all flash, and you do flash so fast that it runs at much closer to memory speed, you can start utilizing your CPUs at 67 and 80% utilization. And that means a lot less equipment, a lot less cooling, a lot less licensing, and a lot less patching and maintenance. And some of our performance gains has been a report in the old infrastructure, now ran in 7 minutes in the old infrastructure, it now runs in less than 7 seconds. And this was a one-to-one migration when we did a combination of the all-flash and the SQL Server features in SQL 2016. It did much better. A business intelligence query ran orders of magnitude faster, a factor of 9,521 times faster. And I'm also a database administrator, and I can say on behalf of the DBA family that it is not often that performance gains exceed our expectations by a huge margin. That. So please let your DBA look at the new features in SQL 2016. We are skipping some of our data warehousing solutions because many of our business intelligence queries can be serviced directly from the OLTP instances without any significant impact. And also reducing the overall resource on the infrastructure. And this is HTAP, the hybrid transactional analytical processing. It makes so much sense. This was part one of our journey. We also did high availability. We need good numbers in all disaster recovery scenarios. So we cannot reinvent the manual operations and are completely dependent on our IT infrastructure. The initial design plans involved many discussions on how to do site-to-site replication. We looked at various third-party vendors, hardware and software-based solutions, quite expensive, very expensive, some of them. We do Hyper-V replicas for the application servers. And so we only needed something with SQL. So we looked at SQL always-on availability groups. But at our time of choosing, it had some limitations in terms of bandwidth limitations and also feature-wise. We did not support distributed transactions. So we also needed a solution that was as simple as possible. Best case, not requiring a DBA. So it was quite limited, our choices. We also needed good RPOs and RTOs, the return point objectives and return time objectives. And I cannot go into all the details on why we chose what we did, other than simplicity comes years afterwards. We have lots of demos, but storage replica in Windows Server 2016 is a very good fit for us. It solves many of those problems. And for those of you who do not know, storage replica is a storage agnostic, application agnostic, block level replication mechanism. It sits way below the file system, built right into the OS. You have write aggregation for faster replication speed, one-click failover, no need for a DBA, very easy maintenance. One line of PowerShell for setup, one line of PowerShell for failing over your entire cluster setup. And we ran tests for months on the technical preview 4 and decided to go into production and have been running in production for almost a year now, currently on technical preview 5. And storage replica is stable and very fast. So all of this is a very short version of a very good story on paying less money to Microsoft. So minimizing the licensing costs, maintenance hours, and also doing very good on the RPOs and RTOs, and maximizing the performance, and easily keeping up to date with the patches on the OS, on the SQL instances. So we are patching during production hours without any outages. And we have been a member of the Windows Server TAP program and have been collaborating directly with the storage team. So thank you, Elton, Ned Pyle, and Klaus Jørgensen for a continuous rapid response time on our feedback. You've been great. And on a final note, we're also a cloud customer doing CRM Online, SharePoint Online, Office 365, and we do have a cloud strategy. But from our perspective, Windows Server 2016 is Microsoft saying, you have not forgotten the on-premise guys, so thank you for that, Microsoft. Now there are also some important design decisions, pitfalls, and even some very dark stuff we've had to go through. So we would like to discuss and share some of our real-life experiences. And Michael and I will be available afterwards and the rest of the week, talking with everyone already going through or interested in similar infrastructure changes. Thank you.
All right. Thank you, Morten. Thank you for sharing your experiences. All All right, so let's keep going here. Next feature I want to talk about is site awareness. So as I talked about, with clusters, we've supported stretching them across sites since the Windows 2000 days. But a cluster is really completely agnostic as to where the locations of the nodes are. And we knew that if we could introduce some sort of awareness of fault domains, and we've actually introduced a full-blown version of fault domains. And so we actually have fault domains at node level, chassis, rack. And what's most interesting from a SQL perspective and for stretch clusters is around sites. So we've introduced the concept of sites. And what that allows us to do is to be able to have more intelligent failure policies from a SQL perspective. So it's a way of saying, hey, when something fails, so let's say I have 2 nodes in one site and 2 nodes in another site. In the past, things could fail over from here to here. What we're going to do now is we're going to say, hey, always try to fail over to a node within the same site and make sure you exhaust all the nodes within that site before you go and try to fail over to the other site. And so we have policies like that and trying to keep things co-located. And we have logic that you can define a preferred site. So here's my primary data center, here's my backup data center. If you have to kick out a node for any reason, because I have some sort of asymmetric network communication failure, and you need to kick out a node, kick out the DR site ones because they're not as important. So we just have a bunch of failure policy logic we built into clustering to take awareness of this. So now if you're doing stretch clustering with 2016, we're going to have this awareness. Another thing we did in this journey around enabling better disaster recovery with clusters and with Windows Server 2016 is we introduced this thing called a cloud witness. So if you're stretching one and you've got 2 nodes on one site and 2 nodes on another site, we always want to have some decision maker in a third site so that if you lose a complete site and you lose 2 nodes, that we can have 2 votes plus a third vote to decide. And our story for the last 10 years has always been go configure like a file share witness and put it in a third data center. And the first thing everybody says to me is they go, Eldon, I don't have a third data center. You can't ask me to go stick a file share witness in a third data center. And so that was always a challenge. So now we're going to have the ability to use Azure Blob Storage as a decision maker for the witness. And so let me actually just kind of show you what it looks like. So I'm going to give you a little demo. So here's Azure, looking at the Azure portal, and I have no containers defined. I've created a storage account already, but I don't have any storage containers defined. So I open Failover Cluster Manager, and I just go into the wizard, just like I normally would. I'm going to choose a new witness through the same quorum configuration wizard, and there's a new option called the Cloud Witness. So you configure the Cloud Witness, and it's going to ask me for my Azure storage account name. So I just go into the portal. And the nice thing about the portal is it has this very handy copy button, and it's going to come in more important on the next step. So I put in my account, and then the next thing is the key. And unless you could type that, which I couldn't type that on a dare, you put in your key, and that's all you have to do. So you give it your account name and your key, and then we're going to go and connect and use Azure as a backend. It works exactly the same as a file share witness. And so I have a file share witness, and that's it. And so it works exactly the same as a file share witness. It doesn't actually store any confidential data. It's just copying. It just stores a copy of the Paxos tag up on top, up on the Azure Blob Storage. It's a very, very small amount of data, so you have to pay for egress of data from Azure, but we're using it so sparingly. Next question is people always ask me, actually I'm leading into my own question, which is people always ask me like how much does it cost? And there's kind of this cool thing about Azure, there's a rounding error. They round to the nearest penny. So far in all our testing we haven't been able to get to a round to a penny yet. So I'm not going to promise you it's free, but it's pretty darn cheap, let me say that. Maybe you get it to a penny, maybe 12 cents a year at most, I'll say that. So it's a very easy way to set up clusters now. Much easier than using a file share witness, especially with stretch clusters. All right, so let me talk about quarantine. So another feature we introduced in 2016 is a feature called quarantine. And so what quarantine does is that if you have a flapping node, and what I mean by flapping, like something's going on with the node. So it's coming into the cluster, it's going out of the cluster. It's coming into the cluster, it's coming out of the cluster. It's got a networking problem. It's got some problems coming in and out and in and out. And so this can be very disruptive to the cluster. The SQL is trying to resynchronize all the metadata, trying to get things resynchronized and in and out. So now we have the ability that if we see that a node is coming in and out multiple times, we'll quarantine it. So we'll say, man, you got problems? You're not allowed to play in the sandbox with everybody else. We're going to go kick you out, and we're going to leave you out for a little while in case of transient failure. So it's 2 hours by default. You can configure it. I've had a lot of people say to me, hey, if a node's having repeated failures to the point that it's gotten kicked out of the cluster, I want to go take action. You can actually do that. It's configurable. You could effectively set it to infinity. And so that way the node will never come back in. Then you get an event from ops manager, then you go take corrective action, then you decide when you want to come back in. So that's the other kind of scenario. And with that, now let's talk about performance, and I'm going to bring up Kevin again.
Thank you. So there's been a number of interesting developments in the performance, and especially when it comes to storage. SQL Server has, for a long time, had leading TPCH benchmark numbers for data warehouse performance. We're the #1 for 1, 3, and 10 terabyte data warehouse benchmarks. We've also got a 30 terabyte benchmark number out there that was #1 until a very small company came and nudged us out. But we're industry leading price performance across the board. And for a lot of that, we rely on the platform we run on. One of the interesting things that's changed is the amount of memory. You can now have up to 24 terabytes on a Windows server. SQL likes a lot of memory. We're really happy with lots of memory. So now this is an actual screenshot of the SQL Server error log showing starting up with, not going to do it. So this is a machine that has 24 terabytes of memory that we discovered. And we actually will allocate most of that in the right circumstances. So it's not just SQL existing on a machine that has this huge amount of memory, but we'll actually make use of it. So that's a pretty stunning change in the environment for us. We'll now use up to 640 cores if you've got one of those mammoth machines. And SQL is very sophisticated at our scheduling, so we'll actually make use of all of those cores. They won't starve cores. If you've got enough parallelism, we'll take advantage of it, we'll use it up. Storage class memory. Who's heard of storage class memory? Okay, cool. So storage class memory is a new leading edge generation of the storage infrastructure. And what this is kind of the blending of storage and memory. There's been a progression in speed. So we have all been around hard drives forever, right? And they have their speed. Some of them are faster than others, but they're not lightning fast usually. SSDs came along and they changed the world, right? They changed the way we think about how fast things can be. They're pretty snappy. And for a long time, SSDs have been the benchmark for fast storage. But new generations of storage are coming out that are way faster even than that. You have NVMe storage that's kind of in between SSDs and storage class memories, and that's PCIe attached storage that doesn't use the SATA bus. So it doesn't use those protocols. It's a much more efficient protocol. Storage class memory is RAM, DIMMs, so NVDIMMs, non-volatile DIMMs. So you have DIMMs. One of the form factors is just a regular DIMM plugs into the memory slot. One side it's got DRAM, the other side it's got flash, and it's got enough of a capacitor to have the energy to pull all the memory, all the data from DRAM into flash when the system goes down. So the impact of that is that you have now something that can respond very close to DRAM speed, which is just stunning, especially for write access, because you're not hitting the flash all the time. The only time the flash gets hit is when the system goes down. When you come back up, that data all gets pulled back into the DRAM side of the DIMMs, and you have access to all of that data. We could do interesting things with that, right? So one of the things that we've done is that the gate to performance in SQL Server is going to be the transaction log, writing to the transaction log, because every commit has to be hardened in the transaction log before we'll continue on with other work and before we'll acknowledge that transaction's the application. So if we can get that faster, we can make SQL run a whole lot faster. So there's one approach was put the whole log on storage class memory. NVDIMM is supported in NVDIMM-N is supported in Windows Server 2016, so we've got the working blocks to work with. storage class memory gets exposed by Windows as a volume. So Windows recognizes that this is a storage class piece of memory and surfaces it as a volume. The volume can be formatted either in block mode, so it looks like just another drive that's just really fast, or it can be formatted for what's called DAX mode, direct access. Direct access, again, looks like a volume in the file system, but if you've ever done memory mapping of files, you can create a file on there, you memory map it, and traditionally that's a region of memory that is mapped to your on-disk file, and the operating system is responsible for moving bits back and forth. In this case, they recognize that this is storage class memory. This is non-volatile storage, so they just map that region into your memory space, and that is the memory on those DIMMs. So as we write data into that file, actually into that memory space, it is persisted on the NVRAM. That means we can go on without ever doing the I/O. So this is using the byte addressable log. What we do is we assemble the log records in a buffer before we write them out to persistent media and flush the buffers and all that work that we typically do when we're writing out the log records for commits. With this, we use the NVRAM, the DAX object, for our log buffer. So as those records come out of the processor cache, they go directly into that region of memory, and we don't have to wait for the whole I/O system to flush it out to disk because it's persistent. If the machine crashes, those records are already there, persisted. We'll use them at startup time. This is a couple of benchmarks that we did using Hekaton, the memory optimized OLTP features. The first column is on NVMe, so this is the very fast SSD in block mode. So 63,000 updates per second. Average time is about 379 microseconds. The same thing with the DAX mode. So you tail the log on the DAX volume is much, much faster. So you're like about twice the updates per second and about half the latency. Again, the latency is under a millisecond there. That's a tenth of a millisecond about, or 2/10. That's a pretty stunning speed. So let's see what that looks like. So we have a demo here, demo.ps1. We're going to start by running some workload in SQL against an NVMe SSD. So this is Fusion IO was the brand name that a lot of people knew, the first generation of this. There's a lot more. I'll be doing a demo later on that shows, uses a Samsung NVMe devices in a cluster. So again, 63,000 updates per second. Average time per transaction is 0.37 milliseconds. Doing the same thing with the DAX, tail the log on the DAX volume. And again, these are both timed runs, so that's the same amount of time, elapsed time for each run. 124,000 updates per second. And update time is in 0.19 milliseconds. That's pretty stunning speed. So this is some of the things that we're working on the leading edge of storage that can really bump up your performance. And at this point, I'll let Eldon come and explain Storage Spaces Direct.
All right, thanks, Kevin. So the next thing that's kind of interesting is happening around storage. So we're introducing this feature in Windows Server 2016 called Storage Spaces Direct. You might have heard of us. We talk about this when we talk about hyperconverged. We talked about it in one of the keynotes. We've had several sessions, and what you hear all the noise about is all around hyperconverged. What we're announcing right now, right here, is that we also support running SQL on top of Spaces Direct. So you can take a set of commodity servers, you can take those internal local drives, and using Ethernet, nothing fancy, no external storage, no external SAS cables, set of servers, internal local drives, Ethernet, and then we will replicate them across to create a virtual storage across them. So we will take all the storage across all the nodes, we will pool it all, and then it'll just look like under C cluster storage, it just looks like normal storage. And then you can run SQL on top of that, both FCIs and AGs. So with that, let's see it in action. So why is this cool? We're going to see this in a second.
Okay, so what I've got here is a configuration. I've got a copy of a 1 terabyte TPCH database restored onto a hard disk volume and onto an NVMe volume. So this is in cluster storage, right? Storage space is direct. So we're executing a query. We're looking at how long it's going to take to run the query on the hard drive. So I just skipped ahead a little bit. So the total time it took to run that query against the hard drive volume was 1 minute and 25 seconds. Now we're going to switch over to the other copy of the same database restored against the NVMe volume on storage spaces direct. So this is spread across 4 nodes. We're using Mellanox networking gear and Samsung NVMe cards. Total of 15 terabytes, 3-way mirrored. So 5, 6 seconds. So the other one was 1 minute and 24 seconds, right? 12 seconds. Same database, same query against the storage spaces direct volume. That's what this gets you, is the ability to aggregate the fastest storage on the planet. So let's see what the platform can do. We're going to use disk speed, which is a disk benchmarking, or speed I/O benchmarking tool, to see how fast we can drive reads, simulating a data warehouse query against this same volume that we were using for SQL. That's a lot of digits. That's 25 gigabytes a second read speed coming out of that storage spaces direct volume. Again, spread around 4 nodes in the cluster. We're running from one of those nodes. That's incredibly fast speed. That gives you the ability to do a whole lot of analytics really fast.
Does it make sense? You're taking those NVMe devices inside the servers, which normally cannot be shared, and we're unlocking the capabilities of that storage. It also, with Storage Spaces Direct, you can unlock new classes of drives. Usually shared storage has to be multi-initiator capable, right? So you got to have SAS drives. You got to have expensive SAS drives. You want to use SSDs, you want to share them across a set of machines, you got to buy some very expensive SAS drives. Now you can have, even at a capacity level, we're showing you performance, an incredible performance, but you can have low-cost SATA drives if you just want capacity inside your servers and now have them be distributed and synchronized across all the nodes.
Anybody impressed by that? Okay.
All right, so just kind of a recap here. So that's everything. So we got the most secure platform. If you care about security, this is the platform to look at. Performance, we showed you industry-leading performance. What we're doing with storage class memory, with Windows Server is the only platform that can do that. What we saw with storage class memory, we are industry-leading in what's happening there in your capabilities. We showed you storage spaces direct that can take those internal drives. We talk about hyperconverged, and that's what you see us talking about. What we're announcing is SQL, and that this unlocks all kinds of new and interesting scenarios for SQL as well. And we talked about flexibility. You're going to be able to do rolling upgrades to get there easier than you ever have. You're going to be able to deploy in domainless, multi-domain. You got Cloud Witness. You got enhanced failure policies. They're going to make stretching these SQL clusters across sites easier than they've ever been. Okay, and with that, any questions? It looks like we got just a couple minutes. Anybody have any questions? Yeah. Yeah, so the question was, on the slide, it's on quarantine. So the question is about quarantine, and there's a point that we will only quarantine a maximum number of nodes. We do that so we don't end up quarantining all the nodes in the cluster. That would be bad. So yeah, we'll quarantine up to 25%. So if you get a 4-node cluster, then we'll only ever quarantine one node. Then it will still be 1 node. We'll still only quarantine 1 node. Yeah. Good question. The question was what if I had 3 nodes? It'd still just be 1 node. Any other questions?
Yes,
yeah.
over here.
You mentioned 2016 we can create a cluster without AD. How about the FCI? Can we create like SQL FCI cluster without Active Directory?
Yes, you can. Yep.
Even with the storage space direct?
Yes, you could even storage spaces direct. You could do a domainless storage spaces direct, and you could do the domainless FCI.
How we take care of the authentication there?
How do we take care of what? Excuse me.
Authentication?
Oh, you're saying like intranode authentication?
Yeah, yes.
So in that case, you would be doing like SQL auth. We've actually switched all the cluster infrastructure, so all the intranode communication between the nodes in the cluster, we've switched over to certificates. So we've switched over to these self-signed certificates that we use for intranode authentication.
Gotcha. Thank you.
And we do that for all scenarios. So it's not a special mode when you run domainless. All clusters now, whether they're domain joined, multi-domain, or domainless, all run certs now for intranode communication. Good question.
So the question is, for storage class memory, do you need special hardware besides the actual memory itself? I believe there's certain vendors that have the hardware for that on the motherboard.
The only vendor that has it today is HPE. So they have their Gen 9, DL360, and DL380 servers that support NVMe.
So currently HPE has Gen 9 DL380s that support this.
And Toby is if you have any questions about storage class memory, he is the storage class memory PM. Klaus
guy.
is the Spaces Direct PM if you have any questions as well afterwards you want to talk to him. So we got a bunch of people in the room if you want to ask specific questions afterwards as well. Other questions?
Yes.
Yes, one more. So for this SCM, so can we use SCM in a virtual machine?
Can you storage class memory inside a virtual machine?
Yes.
So could you,
Can we expose this to the virtual machine?
So the answer right now is the only way to do that is to create a VHD on the storage class memory and expose that to the VM. The capability to expose it directly is not there yet.
so just to repeat it, so just repeating Toby's answer here. So you can't expose it directly, but you can expose it as a disk and then create a VHD on top of the disk.
But
Thank you.
that doesn't allow you the direct access.
Not yet is the key word.
Anything else?
All right, thank you very much. Hope you enjoyed it.